What you see here is Yamata no Orochi, a Japanese monster. And we all have our monsters. This particular monster was first found in Japanese literature in the year 720 or so. So it's a very, very old legend about this crimson-mouthed, seven-headed, seven-tailed dragon, I guess it is. Technically, it might be some sort of snake. This dragon had a very bad habit that each year it went down to the neighbor village and devoured the most prominent daughters of the most prominent citizens of this village. Yamata no Orochi wasn't very much liked because of this. And the villagers, eventually, this is a very complicated story, they hired the outcast Shinto god Susanoo to slay this monster, and eventually he succeeded. If you try to read up what the story really is about, it's incredibly confusing, sort of like the puppet indirector or something. You get very, very confused. Now, the point here is that Yamata no Orochi has very much been the archetypical monster of Japanese monster movies. And I don't know, do we have like Godzilla fans here? Right? Woo, way too fast. So we Godzilla fans, the three-headed monster, the King Ghidorah monster of this monster movie called The Greatest Battle on Earth, where Godzilla became the good guy fighting the monster. And the monster was actually modeled after the seven-headed dragon that you saw earlier, only they couldn't really animate all the 7 heads, so they ended up with 3 and 1 tail, as you can see. At Puppet Labs, well, you already saw the picture, we have our own monster. But we have 2 heads. And this monster, of course, is the loose semantics, non-existing semantics, all the what the fuck is going on that you see in the Puppet 3. And in Puppet 2.7, one of the heads were sewn on backwards, so you don't really know how the hell this thing worked. So yeah, I'm here to talk about fighting this monster and creating a new one called what is the Puppet Language 4.0. You see my contact details there, Twitter and email. So in Puppet 3, there are some behaviors, bugs that we have, and here depicted by Mothra, the big bug, coming to fight Godzilla. I don't know what the plastic tent is, but I think it's a nest for Mothra that they built. Our bugs are, of course, much cuter. They are now reacting to what we're doing. They're hearing the lid coming off the can of DDT that we're applying to it. Now, some of these behaviors are really bugs, but we've sort of taken them to our heart, like Gonzo in The Muppet Show. I guess you've all seen The Muppet Show, right? Yeah. So, you know, Gonzo comes on with his, like, singing chickens, or he's going to play the trumpet, only he swallowed it, or it goes horribly wrong. But we've sort of gotten accustomed to that is what happens when Gonzo comes on stage. And it is the accepted behavior, and it's normal. We use this every day. It comes on, and it sounds like awful, but yeah. So should we keep that behavior, or should we not keep it? And you know, what should we do? So what we've done, I mean, we've carefully renovated the Puppet runtime. I mean, ripped it apart actually, and re-implemented a new strand inside of logic, a new stream of logic inside of Puppet. And it's been hiding behind the feature switch and what you get when you turn on the future parser. And it's been available since 3.5. And we've been adding more and more features to it. And the intent is that now that Puppet 4 is going to come out sometime end of this year, that will now be the standard. And at that point, there will be no future parser because we haven't created yet another future parser. So right now in 3.7, when you turn on future parser, that is to the best of our knowledge, what we're going to release as 4.0 with all the features. There's going to be bugs that you will find, real things in there that we haven't fixed, and we will fix them for 4.0. Just to show you, some of the things in 3x sort of drives you crazy. I'm not going to talk through all of these, but you can just read. And it's like lots of surprises in there. What the hell is going on? Why is it doing that? Why does it work one way but not the other way? And what is it really doing? Yeah. You just want to rip it apart. So that's why we took this other route with feature switches, and it's been worked really great. We've had lots of people try out the future parser stuff. Some even run it in production. Thank you very much for and all the feedback. So now I'm going to talk about what's in 4.0, what we've done. There's some language cleanup things. Sanity, following the principle of least surprise, like correcting the stuff like you saw on the first slide there with some what is going on? There's an interesting collection by Nicholas Fagerlund called Evil Made Manifest. They sit in the repository. We haven't really tried all of them out. We should really go and do that and see what we now can delete as not at all surprising and strange behavior, because now it just works. So that's language cleanup. Another one is internally the grammar was really like 8 different grammars for 8 different parts of the language. Unless you've been into the Puppet logic itself and worked on it, you wouldn't have seen that. You would instead have experienced this as the strange shit that happens when you're trying to do expressions. Why does it work one way but not the other way? Why do I have to assign certain things to a variable? Why can't I pass it directly to a function? Why can't I use this expression in this situation, and so forth? And that's because it was like 8 separate things, because a lot of people hacked on it and they didn't understand how to unify the whole thing. So now it's an expression-based grammar that when we parse, we allow all sorts of nonsensical things to be parsed by the parser, and then we have a separate validation step. And that gives us one of the features I'm briefly talking about, and that is to provide better error messages. Because now the parser can say, yeah, I heard you. I heard what you said, right? Fish bicycles by noon, right? And then the later step can come in and say, this is nonsensical, rather than just saying syntax error on line 8 or whatever. It can do more analysis of what's going on and what you said and what you probably meant and things like that. Then we have a whole bunch of new features, small language features like changes to operators and what you can do in the language. We have some changes to resource expression, new features that you can do with resource expressions. And then we have some bigger items like iteration. We have a type system. You can now use the embedded Puppet templates. Allows you to write templates with Puppet logic in them instead of instead of Ruby. And we have support for HEREDOC, a way to write long, complex strings with better control over them. So what I'm going to do, I'm going to go through all of these. I'm not going to go into every detail. I'm just going to show you samples. So you can see, like, these are some of the new operators, what they can do, and then get a general feel for the major new features. Cleanup. One of the first things we said was that we really need a specification. We need something that defines what the language is and how it's supposed to work. And now we have written a specification. This is not user documentation. This documentation is intended to be the truth of what is the language supposed to do. How does all the operators work? How does the different data types work? How does the type system work? And so forth and so on. And we have this in a repository. And you see the URL of that there. And if you really, really care about the language, we very much appreciate people reading this, asking questions, finding typos, or when we've done something wrong. because this is what is guiding us when we're implementing the language, what is right and what is wrong. So some of the other cleanup things, numbers are now numbers. This is a big change. Puppet has always had one data type, and that was string, and array and hash. But everything was strings, which was really, really difficult because it causes lots of the confusion like you saw on the earlier slide. Now, if you have written something that looks like a number and you haven't quoted it, that is going to be treated as a number, an integer or a float, depending on its format. We've stopped doing magic transformation to string when using matches and not matches and in operations. That causes all the crazy, yeah, you can say that, yeah, there's a 5 in something, but it's not at all the digit 5 in there. It just happens to be that when you magically transform the number from one shape, from a numbered shape into a string shape. Another change is that uppercase bare words. That is, if you write a word that is not quoted, it's text, and it starts with an uppercase letter, then that is always a reference to a type of some sort, like integer or file or package or something. They are no longer strings. A big change is that empty string is no longer undef. And since empty string is no longer undef, it is now true or truthy. So all the if statements that drove people crazy because empty strings were treated as nothing now works as you expect them to work. We've also gone through interpolation, and interpolation had lots of funny behaviors when you wanted to interpolate something that was more complicated than just the name of a variable. Because you could in Puppet 3 and earlier also interpolate other expressions, but sometimes just didn't do what you expected it to do. Now there's a clear specification of what you can do and how to do it. We removed the plus equals and the bracket equals because they made it possible to mutate data. And we have the policy that data should be immutable, or it must be immutable. That is, you cannot change variables after you set them and things like that. These operators weren't used very much. We searched through all the Forge modules, and we only found single-digit use of the plus equals and bracket equals. So we cleaned them up. We are aware, though, that some of you really like Gonzo and his singing chickens. And we have been receiving threats of retribution for removing things, changing things around, that it doesn't really work as it used to. And we think we've done the right thing and cleaning it up, making it sane. But it's not impossible to make us do changes to what we have decided so far. So do test, do tell us about if there are things that really isn't working the way it should. So quickly parade over some of the new features in the language. Small features first. You can concatenate arrays directly with plus, so just add them up. If you apply plus to hashes, it will merge them. It's not a deep merge. The right-hand side will merge on top of the left-hand side. You can delete stuff with minus. So you can, it will remove elements from an array, and for hash, it's based on the key. So you can easily manipulate things. It doesn't mutate, it creates new copies, so the old data is safe. You can append to arrays with left shift operator. Very unsurprising results compared to what you can do in other languages. You can now use unfold or splat. If you precede something that is an array variable with a star, it will unfold it. That is, as if you wrote the elements in place instead of where you use the unfold. And you can use that in various places, like the first example inside of the array, or if you do a case, if you have your cases in an array, in the old logic, if you just do $A there, where in the case expression, and remove the star, then of course it would match with the array, not the individual elements of that array. If I do the star, I unfold it as if it said 1, 2, 3, where the star $A is now. And you can also see the difference below at the bottom, the difference between calling notice with an unfold with that array or with the array itself. It's slightly different. You can take the substring of string. You can search for a substring in a string. So if you wonder if the substring is there, it will now answer that correctly. You can also take substrings of strings by giving index positions, and you can do that with a minus to count from the end. So you can easily pick things out. And why we're doing all these things, you may wonder? Well, it's because people need to do data transformations in the Puppet language. They're looking up data that comes from an external system or is in HEREDOC, and it's encoded one way for one particular reason, but then you want to reuse it, but not quite the same way, and I need to, hack it up a little bit and dig out pieces and all of that. And for that, you have to write like functions in Ruby or use inline templates or make yet another copy of your data massaged externally by some system to get it in the form you wanted. And now we're bringing those operations into the Puppet language to make it easy to do these transformations. You can now do matches with regex where the regex is in string form, and since it's in string form, you can do interpolation. So you can construct your regular expression by composing the string just as you would with regularly with interpolation. Any expression can appear on the right-hand side as long as it evaluates to a string. It will be then transformed into a regex pattern. And as I said, we now have detailed error messages. As long as if an error is a lex error or a syntax error, that is, the lex error is, for instance, you started a string with a quote and then there's no closing quote, then that will be a lex error. It doesn't know what to do, and it'll stop immediately with that error. If there's syntax errors, is that it can't make sense out of it. It can't build a model out of what you said, can't build an AST tree. In that case, it will also give up, and you will get one error. But if it gets past those 2 points, the sort of higher order, more semantic type of errors, they are validated as a separate step, and it will output more than one error if there are more than one, and it finds it. And it will tell you the file and line as it did before, but now it will also tell you the position on the line where that occurred. And this used to be a problem, especially if you had, because errors typically occur on punctuation, such as a curly brace or some operator of some kind. And there's typically more than one occurrence of those on a line where you have an error. So therefore, a small thing like this is important. Plus, it knows more about what's happening and more about the context, so it can give you a richer error message. Now, since everything is an expression, there's no difference really between the different types of things you are expressing in the language. So for instance, if and case are now expressions. They produce an R value. So you can do things like this. Earlier, if you wanted to do something like that, you had to assign the result to a variable first and then notice it. Now you can do notice if 1 bigger than 2, then true, else false. So since 1 is not bigger than 2, it will notice false, right? And I didn't have to assign it to a variable or anything. The entire if expression just evaluates to the last thing that was evaluated for it, in this case, false. And the same thing with the case expression. So you can use them immediately in an expression. We've done some things to the resource expression. We had a long discussion first on the development mailing list, and then we did some usability studies on on this, and we arrived at a couple of features that we wanted to add to the resource expression that now looks like this. First of all, we have something that we call local defaults. If you have a resource body inside of a resource instantiation expression like this, and you give it the title of the literal default, the values you set there, the attribute values, will be the default values for the other bodies inside of the same resource expression. And this is of value because we have another resource default mechanism that allows people to set what the defaults should be per type. And they unfortunately have dynamic scoping, and they can affect resources far away out in other modules. And if you're a module author and you really care about not having someone else's defaults invading into your module and causing havoc, you need to have a way to ensure that what you say about resources inside of your module is exactly what you want them to be. This is a mechanism that allows you to ensure that the defaults will be picked from this local default and not from some other place. And you can then very easily override it and you see exactly what you're doing. Now, if this was the only thing we did, you go crazy because you had to spell out mode, owner, this, that, or so. We have another feature, and that is you can now do unfold of a hash inside of the resource declaration. You can use that for the default, or you can use that for other resource bodies. So we ended up with this syntax where instead of the attribute name, you can give a star, and the star means like a wildcard. So pick whatever is on the right side, which has to be a hash, where the keys are attribute names and the values are the values you want to set. So now you can do this thing. You can set up a default hash, and then you can have that applied for the other bodies inside of this resource expression. And you can also do that, mix it in with explicit parameters, and then fold in the values from a hash. The question, what gets precedence?
Yeah, let's say modes and params hash in the temp, for example. Which one gets precedence? Does one get precedence, or is that an error?
It's an error if you specify mode in both. So it now gives you an error. It's the same as if you had entered mode manually twice. That has the highest precedence, and then if something is in defaults and you haven't specified something, it'll get that. And then the lower precedence is the global defaults that you can do as you could in 3x. All right. And finally, the third option is that you can have a dynamic reference to the type by using what I will explain later, the type system. And here it says resource and a $type. That means you can feed in which type it is by a variable or an expression. You can have a string there if you like, and then set things. Then actually what you see now is what the function create resources does. Only now you have it in Puppet language. And the idea here is that, of course, you shouldn't use this for everything, but you start with statically declared resource, and then you realize, oh, I need a couple of parameters in here because really my defined type is parameterized, and one of those parameters has to go in 2 or 3 different places. And if you had them now statically, what you would have to do is to change completely your logic and then use create resources and then flip the whole thing over to be completely in a hash and then call that function. Now you don't have to do that. Now you only have to, since you can then get things in from a hash directly into the resource, do whatever you want to do, but you could do it in a gradual way, not forcing you to rewrite the whole thing just because of that. All right. Next thing, if you've been following what we've been doing with the future parser, this won't rock your socks off. And of course, I'm talking about loops, iterations. You've probably seen examples. what you can now do is you can iterate over arrays, hashes, strings, and integer ranges. And this is implemented as functions, and we've added the ability to have callable code blocks that you can express in the Puppet language. That is lambdas. And this creates an open design. We also added the ability to be able to express a sequence of calls from left to right using a dot notation. And it will all make sense on the next slide. So using both the function call notation at the bottom and the dot notation above. So you can read the first one there as the array 1, 2, 3. Take each and pipe them as the variable x into the code block on the right there, and notice each x. So if you run that, it will notice 1, notice 2, notice 3. And the example at the bottom there is exactly the same thing. It's the same function call. It will do exactly the same thing. So you can choose which one you want. Now, the dot notation makes most sense when you want to continue the expression. What if you want to loop it first for one reason and then for a second reason? That you don't have to repeat the 1, 2, 3 side. You could just do a dot at the very end of that and then continue the expression. That makes it easier to read it from left to right rather than having them nested inside of function calls. I'm not showing any examples of that. You just have to trust me for that. So I'm going to show like 4 or 5 of these functions and what they do. So each just iterates over it and passes each onto the code block. The return value of this expression is the left-hand side. You get the array back. We have map, and you use map to transform each element and then produce a new structure with the transformed result. So here I'm doing the same. I'm piping 1, 2, 3 into the code block, and I'm multiplying each by 10, and which gives me the result of a new array with each value multiplied by 10. This is really easy to use. We have a filter, and you can probably guess what it does. It produces elements that matches whatever. So if it returns, the block returns true, it means I'm going to keep this element. So if I filter 1, 2, 3 and give it a predicate that x should be bigger than equal to 2, of course I get the result 2 and 3. Reduce, it's also a transforming function. It reduces many to 1. And you can reduce it. Typically you reduce to something like an array or a hash or something that you're computing. Here I'm just computing the sum of 1 plus 2 plus 3. So the first iteration, the result on x will be the 1 and 2 from the array. And then it adds them up, which produces the value 3. And then it feeds that back into like a feedback loop back into the new result in the next iteration. So then it will be adding that result 3 plus to the final digit 3, and the result is 6. When I'm in that code block, I can access things also that are outside of it. You can see the variables outside, so you can take them into account. But this is really useful, like for building like a complete different structure than what you started out with, where map is like a one-to-one map between your input and your output. There are other functions. We have a slice function, hacks up an array into chunks. The each map and filter you can get the key or the index number. So if we were iterating over something, you get index 0, 1, 2, 3, etc., so you know where you are. And for hashes, you get the key and the value. Now, you can write your own functions also that behaves the same way. So you can write, we haven't written a full library yet. I expect there to be an addition to standard lib with things like any, or is there one thing in here that matches a condition? All, does all match a condition? And find and things like that. It's very easy to write one of these things on your own. Now on to the more theoretical part of this presentation. This is the Muppet Old MacDonald. And Luke has inspired us to do something silly on stage, so I thought I will do a little sing-along here. So I hope you're alert. And that you join me in the song. I'm sure you all know Old MacDonald Had a Farm. And when you see a picture come up, I want you to shout out what it is you see on that picture. Okay? Deal? All right. Okay. All right. So, Old MacDonald had a farm, E-N-E-N-O, and on that farm he had a... Yay! I thought I heard a Swede here. Someone said meatball? All right. Okay, all right. Now you know what you know. So feel free to sing along as well. So, Old MacDonald had a farm, E-N-E-N-O, and on that farm he had a E-I-E-I-O, with a moo-moo here and a moo-moo here, here moo, there moo, everywhere. Old MacDonald had a farm, E-N-E-N-O, and on that farm he had a... You figured this out, right? Yeah, string. Old MacDonald, I don't know what a string sounds like, so I'm going to skip that. All right? So Old MacDonald had a farm, E-N-E-N-O, and on that farm he had a... Now you're confused, right? This is an integer. It's the integer 42, right? So this was the first sing-along introduction to a type system that you'll ever hear. You can replay it and laugh on the video. So what did we do here? Well, we all acted as a type system. And what is a type system? Well, it's a pattern recognition, pattern matching system that looks at something and then says, oh, that's one of these things, right? So we saw that picture and we said, cow. That's not a cow. That's a Muppet. It's fabric and foam rubber, right? No one said that, right? Because we recognize it as a cow. Our pattern matching system said that's a cow, and we assigned that name to it. We were more confused by integers, just like Puppet 3, actually. You're all destroyed by how Puppet 3 works. All right, so we have a type system, and basically that is what it's doing. It's sort of like regular expressions applied to some data that it sees, and then it can say, all right, so that is this type. It is this abstraction, and we've given it a name. So now Puppet types are first-order objects. They can be assigned to a variable, passed around. We use familiar syntax from resources, i.e., you already have been using the type system because you've been referring to file, user, class, etc. Those are now references into the type system. But now we have other types like integer. So here's some simple examples using integer. So if we say integer with a capital I, that means we are referring to all integers that we can possibly have in the system. We can restrict that by giving it a parameter and say integer 42. That means all integers that are 42 or bigger. And we can cap that range. So integer 42, 142, that is, of course, all integers in that range. To be more technical, our types are so-called dependent types. They know more about the type than the actual base type. It knows about the value also, or a range of values. If it's an array, you can specify things like the length of the array, what the content of that array is supposed to be, and so forth. I'll show you all the types, but first, sort of how you can use this. You can get automatic type checking, and you saw this in Luke's keynote, how much code and problems this can save you, just by declaring the type of a parameter in your type, for instance, like so. So my type takes an integer that is between 80 and 443, and that's the port. And now it's guaranteed in that code that this will actually be an integer, and it will be between 80 or 443, or Puppet will give you an error message and say that this is not a compatible type and why that is so. And that saves you a bunch of calls. And especially if you're doing something complicated, like in the example that was in Luke's keynote with, sorry? Validation, right.
So with that example, that'd be an integer between 80 and 443. So the spirit of what I think you're going for there, if that was like a web server module, where you wanted to solve that, would it? Somebody could put in 100, and that would match, wouldn't it?
That will match here. So you would not want a range, you would want certain discrete numbers. Yeah. You can do that. We have a type called a variant type that allows you to do things like that. You can even say it can be the string red or the value 46. You can do things like that. I'm going to show you some examples first of additional examples, and then I'll show you all the types and just a really quick thing what you can do with it. If you want more advanced type checking, you can use the type, and we have a function called assert type. That is what the system is doing automatically, but you can take over instead and say, I want to do it myself. And then you have a code block that gets called if there's something wrong with the value. So if you want to, you can have a much better user experience by telling the user in more detail what was wrong. Or you could say, you have said 100, that's more than what I allow. I will use the maximum of 50, and then return a default and continue after issuing a warning. You can do operations on type. Since they are kind of a pattern, you can use the matches operators, matches and not matches. So you can check in your own code, as you see there at the below, $x matches integer. Now that matches against type. You can use the comparisons to see if one type is more specific than another, and stuff like that. Right, skipping on to the type hierarchy. First, the sort of the obvious things, like it supports scalars, like numeric and string, but we also, and integers and float have ranges to and from. String can have a size range, so you can say it has to be a string that is not empty, or it has to have at least 3 characters, no more than 10. You can do enumerations. That is like, it can be red, green, black, or blue, but nothing else. Or you can do that with patterns. It has to match one of these regular expression patterns. Or it's a Boolean, or it has to be a regular expression. So you have to give me a regular expression. We do collections. It's an array or a hash. And when we have those, we can specify what the element type of that array is. And we can also, it doesn't show here actually, but you can specify the minimum and maximum length of that. We can do something that's called a tuple, which is a sequence of types. So I accept an array that has 3 integers and then a string, and that string cannot be empty. And then you just use the tuple type. And struct is a subtype of hash where you specify the expected keys and the expected type per key, which is awesome to have. Like if you're accepting a hash from HEREDOC and you're expecting it to have a certain keys and certain types of values, you can then type check it with one reference to a struct that says what the keys should be and what types they should have. We have the variant type that allows you to say it's a cow or an integer or a cookie, right? You can just list a bunch of types that you accept. Optional means that it also accepts undef. None of the other types accepts undef. So if you want it to be a string or undef, you use the optional and say optional string. And of course, we can describe undef, the literal default, and the types themselves. So the types themselves also have a type, naturally. We have types for catalog entries, like resources and classes, and those are the ones you've seen and used before in Puppet. Now they are in the type system. We also have a special type called data, which is like the sort of what you can get from JSON. It can contain scalars, arrays with data elements, or hashes that have scalar keys and data elements, or undefined, which is sort of an open-ended grab bag of whatever kind of thing, but more safe than allowing data types that cannot be directly represented in JSON. I have links to blog posts that I made about the type system. I don't have time. I mean, it's a full lecture to go through all these types, and I hope I just whetted your appetite with, like you say, oh, it's a really rich type system, and that will really help me. I can precisely define my types. So you have to go and read about that offline. I'm sort of running out of time here. We have a break right after this. So I'm going to be bold and cut into the break. Feel free to leave if you want to. And I'm going to hang around here for questions. I have a few more things that I'd like to show you. EPP, Puppet, embedded Puppet, which is basically like ERB templates, only that the logic is now Puppet logic. So here are some examples. And what's different from in the ERB world is that we can specify that these templates take parameters. That is, they become like functions. And you have to pass those parameters in. And it cannot see the parameters in the scope where you're using the template, which is an enormous problem because they become specific to a particular scope where you invoke these templates. Now you can either have it open-ended and you can decide if you want to pass things in or not, or you can declare it so that the user of this have to give you the parameters. And this shows 3 examples. I leave it to you to figure it out on your own because I'm pressing on to the next feature. HEREDOC. HEREDOC gives you detailed control over a block of text. So HEREDOC syntax here all in one slide. And I'm going to show you examples like this. What you can do here is like you see there it says $A equals and then this end thing up there. That means all the lines from there to where you have repeated that tag, end tag, that is text that should be taken verbatim and be a string. And you have control over where the left margin is, so you can filter out the entire left margin. That's the pipe before the end. You can stack up multiple ones. You get control over the escapes. You can either do that so escapes are all verbatim. This is great for like PowerShell scripts or shell scripts or things in general that you're going to pipe as content to somewhere else, because Puppet will not interfere and interpret backslashes and things like that. It will completely skip that if that is what you want. But you can make it do that by things that were shown on this slide. Again, this takes a while to go through, so I'm not going to do that. But you can go back and look at the slides later, or go to my blog and read about how this actually works. There's a blog post about each of these.
So is that pipe at the end only processed if it's immediately followed by the end tag?
The end tag can be anywhere on that line.
But it interprets that pipe special as a margin
Yeah.
parameter. That's only if it's immediately followed by the end tag?
If it's followed by the matching tag and nothing else on that line. That's true. So it doesn't magically, you do not have to care about pipes in the text. That's true. We have some Ruby API changes. There's a new function API that you might want to go check out because it gives you the ability to write functions that makes use of the type system. So you don't have to code lots of the type checking inside of your function. And we have a binder that we are now going to use more and more to for like plugins and extensions, and you will be seeing more about that later. So just to summarize, language cleanup is more strict. It's a whole bunch of new features, better error messages. You get iteration, you have a type system, and you get the Puppet templates, EPP, and HEREDOC, all in Puppet 4. You can run this now with Future Parser. Idea is that you turn that on, fix deprecations, issues, errors in a backwards compatible way, and then continue running on 3.0, then come back and test again on Future Parser on 3, or on pre-releases of 4. Or if you're bold, or it works great for you, continue running it on with Future Parser, and you're running what will be Puppet 4. You will be doing us and other people an enormous service by being people to try this out. We think it's stable enough to use, but I mean, it's near the edge, but it's not like super experimental. These things will go away. All these features that I've shown you are things we are going to release in 4.0. If something blows up, we'll fix it. And finally, here's some links to Puppet specifications. to my blog post. There's a whole series. There's an index page with like 10 different posts about the type system. There's one about EPP and one about HEREDOC and things like that, all the things I talked about. So like a page or 2 or 3 about various topics. Questions and break?
I have one question about at the cleanup slide, there was something about strings that start with a capital or bare words. Does that mean that we can pull resource relationships from HIRA now with create resources? Before with create resources, if you put that require in pull that from HIRA, it would treat that as a string. You know, you couldn't make relationships with create resources. Is that fixed now? Or?
I'm not sure I really understand where the problem in that resides and if that has anything to do with it. Yeah. Maybe we can discuss it afterwards and see if I understand it better. So, more questions?
So, I haven't played much of Future Parser. When is that introduced? What version of Puppet 3?
3.4 was the 3.4, and then in 3.5 we switched. Okay, when was the Future Parser introduced? It was introduced in 3.4. The first versions were only parsing, and then in 3.5 we turned on the Future Evaluator, and then that took a whole bunch of new logic that we do the new way, and that was basically to get rid of a lot of the what is this thing doing? We also broke a whole bunch of things in 3.5. People found lots of problems with what we were doing, and then we fixed them in 3.6. And then we've elaborated on it, and now in 3.7, it's...
So to be safe, if I really want to start writing Puppet 4 compatible code, I should be running 3.7.
Yes, yeah. That's true.
Ever since Puppet 2, we struggle with parameterized classes. The problem of inheritance. You inherit from a parameterized class, you can't override the parameters. That's been a long-standing thorn. Did you guys think about addressing that in Puppet 4?
So the question is, we've been struggling with inheritance and parameterized classes and what you can and cannot do with that, and have you given that any consideration in Puppet 4? What we've cleaned up and fixed up to this point is language itself. We have not yet fixed what is in the catalog and what is in the domain of the catalog compiler. So the resources will behave as they did before. Classes will behave as they did before with respect to inheritance. We aim to fix those things. The next thing up on our agenda to clean up is the entire compiler and its representation of resources and inheritance and these things. We don't know quite yet what we're going to do about that, but there's a whole bunch of features that we know we're going to address.
I'm pretty sure that you're talking about from Redmine 5117, which is definitely something we want to fix.
I couldn't hear the Redmine number, but...
I know the bug you're talking about, and yes, we want to fix that.
I mean,
So,
it's been around for 3 years. I don't know how long.
okay, so Eric knows the bug number that's being referred to here, and he says, yes, we want to fix that. So he's going to make sure that we do that. Yes?
So, the work that you've done on the language, improving the language, is really hard. For anyone who's ever implemented a language before, doing this in a backward compatible way is really hard, and I think this is the single best thing to happen to Puppet in a long time. So I just wanted to say thank you, and you did this is an enormous job. Good job.
Thank you, thank you. I wanted to repeat that, but that was...